Welcome to the DIY Honda Garage channel. This presentation will focus on the diagnostic trouble codes DTC P0201 and P0204, which indicate injector circuit malfunctions specifically for the number 1 and number 4 cylinders in Honda Accord models from 2017 to 2023. These codes are critical as they can signify issues in the fuel injection system, affecting engine performance. The fuel injector is an essential component of your vehicle's engine management system, delivering fuel into the combustion chamber. The primary location for these injectors is in the intake manifold, where they spray fuel directly into the airflow. Diagnosing and addressing these DTCs efficiently can prevent engine performance problems and improve overall vehicle reliability. In the following slides, we will explore the error description, possible causes, symptoms, and the extensive troubleshooting steps required for proper diagnosis. DTC P0201 refers to a malfunction in the number 1 cylinder's injector circuit, while DTC P0204 pertains to the number 4 cylinder. The fuel injectors are tasked with precisely delivering the right amount of fuel into each cylinder, enabling effective combustion necessary for generating power. In the 2017 to 2023 Honda Accord, these injectors are located in the intake manifold. They ensure that fuel mixes properly with air before entering the combustion chamber. If either injector fails, it can lead to performance degradation, unwanted emissions, or engine stalling. Each injector is controlled by the Powertrain Control Module, PCM, a computer that also monitors the engine's operational status. Thus, it's vital to investigate any faults within the circuitry connected to these injectors. There are several potential causes behind the DTCs P0201 and P0204. First, a faulty injector relay could interrupt the operation of the injectors, preventing them from receiving the necessary voltage. Since the relay controls the power provided to the injectors, any malfunction could lead to significant performance issues. Second, open wires within the injector circuits may disrupt the electrical flow, causing the injectors not to operate correctly. This could be due to damage or wear, preventing proper current flow. Third, blown fuses can also contribute to these codes, signaling compromised electrical integrity. Each of these issues directly impacts the injector's ability to function, therefore requiring thorough examination. When dealing with DTC P0201 and P0204, several symptoms may present themselves. Drivers may notice engine stalling or failing to start, particularly if the injectors are not functioning correctly, which hinders fuel delivery. Rough idling is another common observation, where the engine's RPMs fluctuate because of an imbalance in fuel-air mixture caused by inadequate fuel supply. Furthermore, reduced power performance may be experienced, especially during acceleration, as the vehicle struggles to generate adequate power due to insufficient fuel reaching the combustion chamber. Recognizing these symptoms early can prevent further complications and facilitate timely repairs. The first step in troubleshooting DTC P0201 and P0204 involves verifying the problem. This includes turning the vehicle to the on mode and clearing the DTC using the Honda Diagnostic System, HDS. The HDS is a specialized tool used for Honda vehicles to assist in diagnosing various systems. After clearing the codes, the next task is to start the engine. If the engine does not start, the technician should crank the engine for about 20 seconds to see if it will then operate. This step will help determine if the issues indicated by the DTCs are still present on a cold start, aiding in the diagnostic process. In this step, the technician needs to analyze whether the engine starts after completing the initial checks. If the engine starts successfully, the next step in the diagnostic protocol should be followed. However, if it fails to start, this could suggest deeper electrical or mechanical issues at play. These issues might involve the fuel delivery system or electrical connections associated with the injector circuits. Understanding whether the engine starts allows the technician to focus on potential underlying causes based on the evidence collected from the initial tests. After confirming the engine starts, the next step is to turn the vehicle off and remove the injector relay from its socket. The injector relay controls the power sent to the fuel injectors, and testing this relay is crucial to ensure that it operates reliably. Technicians typically test relays using a multimeter to measure continuity and voltage levels. If the relay is functioning correctly, we can move on to the next troubleshooting steps. If it's found to be faulty, replacing the relay will likely resolve the injector circuit malfunction indicated by the DTCs. In this troubleshooting step, we focus on measuring the voltage between the designated test points while ensuring that the vehicle is in the off mode with the injector relay disconnected. By measuring the voltage between test point 1 and test point 2, we can confirm the integrity of the +B IGP line, which provides power to the injector relay. Test point 1 is located at the female terminal number 3 of the injector relay socket, and test point 2 is grounded to the vehicle's body. If battery voltage is present, it indicates that the +B IGP wire is functioning properly, allowing us to move forward to the next step in the diagnostic process. Once we've confirmed that battery voltage is not present in the previous step, we proceed to check fuse number A13, which protects the +B IGP wire. Checking the integrity of this fuse is critical because a blown fuse could explain the lack of voltage to the injector relay. If the fuse is intact, it may indicate an open circuit further up the cable run that must be repaired between the fuse and the injector relay. Conversely, if the fuse is blown, a short in the wiring could be the cause, necessitating repairs and fuse replacement before retesting. Continuing through the troubleshooting process, this step requires us to measure the voltage for the +B INJ line while in the vehicle's off mode and with the injector relay disconnected. As with the previous steps, we are specifically testing for battery voltage between predetermined test points. In this case, test point 1 is found at female terminal number 1 of the injector relay socket, and test point 2 is grounded to the vehicle body. If battery voltage is present, we confirm that the +B INJ line is functioning as intended, allowing us to progress further in diagnosing the potential sources of the DTCs. The next step involves checking fuse number A11, which is linked directly to the +B INJ line. Just as in previous fuse checks, verifying the functionality of this fuse is essential to the entire injector circuit's operation. If the fuse is found to be okay, it may indicate that there's an open circuit in the wiring path between the fuse and the injector relay. On the other hand, if the fuse is blown, it signifies there's likely a short circuit issue present that needs to be addressed. Post-repair or replacement of a blown fuse, a retest is warranted to see if the injector circuit resumes normal function. In this troubleshooting step, the technician is instructed to turn the vehicle to the on mode and measure the voltage between two specific test points while keeping the injector relay disconnected. The aim is to determine if there is momentary battery voltage at the injector relay. Accurate measurement at this step is vital, as it can uncover whether the issue lies within the related circuits or components. If battery voltage is confirmed, it indicates that the foundation circuits leading towards the injectors are operational, allowing the technician to continue troubleshooting in the subsequent steps. This step is targeted at identifying issues with the FI main RL wire. The technician must turn the vehicle to the off mode, jump the SCS line using the HDS, and then check the continuity between two specific test points while ensuring the injector relay is disconnected. This procedure helps ascertain if the wire has continuity or if there is an open circuit, which could be responsible for the DTCs. If continuity is confirmed, the system is functioning as expected, and the technician can check for service information related to the DTCs. If not, repairs need to be made to the wire connection to restore proper functionality. After the preceding continuity checks, the next step requires the technician to disconnect the injector relay, jump the SCS line with the HDS, and measure the voltage between the designated test points. This measurement involves checking for battery voltage between the PCM connector and ground. By ensuring the proper current reaches the injector relay, this helps to diagnose if the INJ-RLY outline is responsible for the DTCs. If battery voltage is present, we can confirm the circuit's functionality, guiding us toward the next steps. If not, this suggests a potential open or short circuit issue within this wiring segment. After confirming the earlier voltage checks, the next action involves checking the indicated DTC as seen in the initial troubleshooting verification. The technician must examine whether DTC P0201 remains present. If it is indicated, the technician should proceed to additional diagnostic steps aimed specifically at addressing this DTC. Conversely, if DTC P0201 does not appear, it may signify a transient problem that should be further investigated, possibly linked to poor connections or intermittent failures in the system. This differentiation is crucial to ensure effective troubleshooting and repairs. At this stage in the diagnostic process, the technician will check for continuity between the INJ-H165V and INJ-L165V lines. The vehicle must be in the off mode, and the injector relay should be reinstalled before these checks. By jumping the SCS line and verifying continuity between the designated test points, we can confirm whether these particular lines are operational. If continuity exists, the lines are functioning as expected, allowing us to move on to the subsequent steps. If continuity is not observed, it suggests a potential open in the wiring that needs to be addressed. In this step, the technician focuses on the number 1 injector connector. If the injector connector is disconnected, we will check for continuity between specific test points, once again ensuring that the vehicle is in the off mode. Establishing continuity helps confirm whether the INJ-H165V wire has integrity and is capable of supplying the required voltage to the number 1 injector. If continuity exists, we can consider this wiring functional. If not, immediate repairs will be necessary to correct any compromised segments of this wire, and subsequent testing will need to confirm successful repair. Next in the troubleshooting sequence is to check for continuity within the INJ-L165V line. The technician should evaluate the junctions to ascertain if there is a continuous pathway between the designated test points with the vehicle in the off state. This diagnostic effort is necessary to ensure that the injector is receiving a consistent voltage supply, essential for its operation. If continuity is confirmed, the wiring is intact, and the technician can proceed to replace the number 1 injector if further faults persist. If there is no continuity, immediate focus on repairing the INJ-L165V wiring segment is critical to restoring optimal injector function. In this troubleshooting step, the technician is tasked with checking for shorts to power within the INJ-H165V wire. The connector should be disconnected and the vehicle turned to the on mode. Using a voltmeter, Measure the voltage present at the specified test points to ensure there are no unexpected voltage readings. If there is voltage present when there shouldn't be, this confirms that the wire is shorting to power somewhere between the PCM and the injector, necessitating repairs to rectify the issue. If there is no voltage, we can move on to the next steps confidently that this segment is functioning correctly. Continuing from the previous focus on wiring integrity, the next step is to check the INJL1 65V line for shorts to power. This process mirrors the previous steps, requiring the technician to ensure the injector connector remains disconnected while the vehicle is in the on state. A voltmeter is then employed to measure voltage levels between specified test points. If voltage is identified, this suggests that the INJL1 65V line is likely shorted to power and would need to be repaired. If no voltage is detected, we can conclude that the wiring to the injector is functioning correctly, allowing for progression to the next diagnostic steps. The focus now shifts to checking for short circuits to ground within the INJH1_65V wire. The technician must ensure the vehicle is turned to the off mode and that the injector connector remains disconnected. Measuring continuity between specified test points enables the technician to determine if a short to ground exists. If continuity is found, this indicates that the wire has likely come into contact with ground somewhere along its path, necessitating repairs to restore proper functionality. If there is no continuity, the INJH165V wire can be deemed intact and functional. This step entails further inspection of the INJL1 65V line for short circuits to ground, following the same procedures as previously mentioned. The vehicle should be in the off mode with the injector connector disconnected as the technician checks for continuity. Identifying continuity indicates a potential short to ground, which requires immediate attention to prevent further complications and ensure that proper voltage reaches the injector. Again, if continuity is absent, the INJL1 65V wire is likely functioning without issues, enabling further diagnostic steps without repair concerns. In this step, we shift focus to the number 4 injector connector as part of the diagnostic process for DTC P0201 and P0204. The technician disconnects the number 4 injector 2P connector and checks for continuity across specified test points while ensuring the vehicle is in the off mode. This examination will help determine if there's an open in the wiring of the injector circuit. If continuity exists, the wire is intact. If not, repairs will need to be made to restore connectivity. Targeted checks like this can help isolate injector-related issues effectively throughout the diagnostic process. Noticing the connection and continuity at the number 4 injector is vital for troubleshooting the presence of the DTCs. In this step, the technician verifies continuity for both INJH465V and INJL465V lines. By disconnecting the number 4 injector and ensuring that no open circuits exist within the wiring segments, testing the designated points helps rule out any faults responsible for the DTC reports. If continuity is present, the lines are confirmed not to be open, and the technician can continue troubleshooting. Should any open issues arise, repair of those lines must occur to clear the faults and restore normal function. Once all necessary repairs are executed, it's key to verify that the DTCs have been successfully cleared from the system. The technician should then confirm that the engine runs smoothly, without warning lights or performance issues. Conducting a road test allows for the validation of the repairs in real-world driving conditions. ensuring that any previously observed symptoms have been resolved. It's extremely important to monitor how the engine performs during this phase, further solidifying the effectiveness of the repairs made. Ensuring the reliability of the engine after addressing DTC P0201 and P0204 is critical for vehicle operation. To prevent future occurrences of DTCs P0201 and P0204, it's essential to carry out regular maintenance on the vehicle. Regular inspection of wiring and connectors can help identify wear or damage before it results in trouble codes or injector malfunction. Furthermore, checking the injectors and relays periodically ensures these critical components remain in good working order, thereby maintaining the vehicle's performance. Keeping electrical connections clean and free from corrosion is also vital, as this can significantly affect the reliability of the electrical systems involved. Establishing a routine maintenance schedule will encourage the longevity of the vehicle's injector systems. In conclusion, DTCs P0201 and P0204 indicate critical issues related to the injector circuits in Honda Accord models from 2017 to 2023. Through thorough troubleshooting, including verifying connections, testing relays, and examining wiring, we can effectively identify and rectify the underlying problems. Each step in the process is crucial for restoring proper vehicle function and ensuring efficiency in performance. Additionally, implementing a regular preventive maintenance schedule is key to avoiding these DTCs in the future. By actively engaging in maintenance routines, drivers can enhance the longevity and reliability of their vehicle's components, significantly reducing the likelihood of encountering these diagnostics in the first place. Please like and subscribe to the channel. See you next time.